In this lecture, we'll see the short method of finding particular integral when qx is equal to e to the power alpha x. We'll cover these topics in this lecture: short method of finding particular integral, in particular when fd is equal to y is equal to qx, when qx is e to the power alpha x, where alpha is constant. We'll see the method of how to find particular integral. We'll cover these two examples also. So consider the general nth order linear equation of the form fd is equal to y, where this is equal to an d to the power n plus an minus 1 d to the power n minus 1 and so on a1t plus a naught y is equal to qx, where the coefficient a naught, a1, an are, these are the constants. And what is mean by d? D is nothing but derivative with respect to x. So d is d by dx. For certain particular forms of the non-homogeneous term qx in the above equation, there exists some shorter method of finding particular integral. So we'll see one of these methods in this lecture. Explain the method of finding particular integral of f dy is equal to q when q is of the form e to the power alpha x. Okay, so let us see the solution. We know that derivative of e to the power alpha x is equal to alpha times e to the power alpha x. Second derivative of e to the power alpha x, that is derivative of e to the power derivative of alpha times e to the power alpha x, that will become alpha square e to the power alpha x, and so on. The nth derivative will become alpha to the power n e to the power alpha x. So when we'll operate fd on e to the power alpha x, so when we'll operate this on this, we'll just get this expression, which is nothing that when we replace d by alpha, you can see in these two expression, d is just replaced by alpha, so we'll get this expression. So this is nothing but f alpha of into e to the power alpha x. That is the value of fd when d is equal to alpha. So this expression will get. Further, if f alpha is not equal to 0, then if we operate fd on this expression, so we'll get 1 upon f alpha, fd operated on e to the power alpha x. We'll again get 1 upon f alpha into f alpha e to the power alpha x. F alpha and f alpha is cancelled. So we'll get e to the power alpha x. This means that this is your pi in this case. That is, whenever f alpha is not equal to 0, so this becomes the pi. That is 1 upon f alpha e to the power alpha x is pi, that is particular integral of f dy e to the power alpha x whenever f alpha is not equal to 0. So this you can take this as a formula, that is 1 upon f d e to the power alpha x is e to the power alpha x f alpha, that is d is replaced by alpha. Now suppose f alpha is equal to 0, then what will happen? Then fd contains the factor d minus alpha. Suppose the factor occurs p times in fd. Suppose this factor occurs d times. So fd can be written as simply d minus alpha to the power p phi d, where phi alpha is not equal to 0 in this case. Now we know the shift formula. By shift formula, when fd is operated on e to the power alpha x into vx, then e to the power alpha x comes out, and this d becomes d plus alpha, and this is operated on vx. So this is the formula. Now we'll use this over here. So we'll start with 1 upon fd to the power alpha x. This can be written as, because this expression is this from here, so we'll write this. This expression goes out, 1 upon f phi d applied over here. Now 1 upon phi d is phi alpha is not equal to 0. So this will simply become e to the power alpha x upon phi alpha into 1. We can write here 1. Now this 1 upon phi alpha goes out. Now we'll operate 1 upon d minus alpha to the power p e to the power alpha x into 1. Now using the shift operator, this e to the power alpha x goes out, and this becomes d plus alpha minus alpha. So this is simply become d. So this is this will remain, this will become 1 upon d to the power p1. Now what is 1 upon d? 1 upon d to represent the integration with respect to x. So integration of 1, and this integration will be then p times integration of 1. So this gives x to the power p upon factorial p. So when we'll operate 1 upon fd on e to the power alpha x, we are getting this expression. Now let us see when we operate fd on this expression, what we are getting. This expression is nothing but this expression. Now phi d is out. We are operating d minus alpha to the power p inside first. So e to the power alpha x upon phi alpha x to the power p upon factorial p. So this becomes phi d out, e to the power alpha x upon phi alpha operated over d minus alpha is operated over here. So using shift operator, this expression will become d to the power p, because d plus alpha minus alpha will become d simply. So this expression comes over here, and now when we'll operate d to the power p on this expression, because d to the power p is p times derivative of x to the power p upon factorial p. So this becomes simply 1. Now this phi d, because phi alpha is not equal to 0, so 1 upon phi alpha is out. Phi d operated on e to the power alpha is become phi alpha e to the power alpha x, and phi alpha cancel, so it is e to the power alpha x. So when we are operating fd on this expression, we are getting again the q, that is value of q, that is e to the power alpha x. It means that 1 upon alpha phi alpha e to the power alpha x x to the power p upon factorial p is particular integral of f dy is equal to e to the power alpha x, where fd is equal to d minus alpha to the power p phi d, and phi alpha is not equal to 0. That is, we can take this as a formula that if fd is written like this, 1 upon d minus alpha to the power p phi d e to the power alpha x, this become x to the power p e to the power alpha x upon factorial p into phi alpha, where phi alpha is not equal to 0. So this is the explanation of the method. Now we'll see some examples. So solve d square minus 4d plus 3y is equal to e to the power 2x. Here alpha is equal to, note that it is equal to 2. It is the power of e to the power 2x, that is 2. So auxiliary equation is this, and we find the value 1 and 3. So complementary function is c1 e to the power x plus c2 e to the power 3x. Now here 2, which is alpha, is not a root of auxiliary equation. So simply yp, when we to find yp, we'll write 1 upon fd. 1 upon fd means this, and this is written in factor form. So this will in replace d with 2. So e to the power 2x, this become 2 minus 1, 2 minus 3. So e to the power 2x, 1 into minus 1, that is e to the power minus 2x. Simply in this case, general solution is c1 e to the power x, c2 e to the power 3x minus e to the power 2x. So this is the solution in this case. Now we'll see one more question. Here d3y by dx cube plus y is equal to 3 plus e to the power minus x plus 5 e to the power. Okay, so we'll see this question here in the symbolic form. This can be written like this, and auxiliary equation will become m cube plus 1 is equal to 0, and these are the roots, in this case the value of m. So complementary function is c1 e to the power minus x e to the power x by 2, and all this expression, this is the complementary function in this case. And we are interested in particular integral. So this is 1 upon d cube plus 1, 3 plus e to the power minus x plus 5 e to the power 2x. This 3 can be written as 3 into e to the power 0x, e to the power minus x, 5 e to the power 2x. Now here this 3 goes out, this expression can be written like this. This expression is as it is and 5 goes out like this. Now here there is a no problem. We can replace d by 0 as it is, and this expression will become 3 upon 1 upon 0 cube plus 1 e to the power 0x. Now the third one, here also there is a no problem. We can just simply replace d by 2 and this become 5 upon 1 upon 2 cube plus 1 e to the power 2x. In the second expression, in this expression, because e to the power minus x minus 1, if we put it will become 0, that is, it is a root. So we can make the factor of this, and the factor is d plus 1 into d square minus 1 minus d plus 1 e to the power minus x. And here in this part we can put the value minus 1. This remains as it is. This will write as it is. Here we'll put minus 1. And when we'll solve, this will become 1 upon 3 to the power minus x, this expression as it is. And now here 1 by 3 goes out and we apply the shift formula here. And this will become 1 upon d plus 1 will become 1 upon d plus d minus 1 plus 1. So this expression is written over here. And this become 1 upon 3 e to the power minus x. This become 1 upon d into 1, 5 by 9 e to the power 2x, and 1 upon d is what? This is simply the integration. So this is integration of 1 dx, 5 by 9 e to the power 2x. So this become 3 plus 1 upon 3 x e to the power minus x, 5 by 9 e to the power 2x as the complete solution. This is the complementary function plus particular integral. So this is the complete solution in this case. So by this way, these types of question can be easily solved. You can try these questions. These are questions are very easy. You can solve yourself. Thank you very much.